we have talked about 3 of them. Here are the other 3. And I don't know if you did these other 3 in geometry or whatever. One of them is abbreviated CSC. The word for that is cosecant. Okay? Cosecant. Cosecant is defined as 1 over the sine. Or, in teenager language, you just take the sine and flip it. You just turn it upside down. Okay? The next one is abbreviated SEC. That is pronounced secant. And that is defined as the flip of the cosine. So it is your responsibility to know what these are. Now, how do you remember which is which? Here's the way I do it. There's actually 2 things I have to offer you in terms of tricks. Okay? You see my little red curvies up there. Each of those red curvies starts and stops with a C and an S. So cosecant, its little buddy, starts with the opposite letter, C and S, that it starts with. So cosecant starts with a C, its little flippin' buddy starts with an S. Secant starts with an S, its little flippin' buddy starts with a C. So that's one way to remember it. Another way to remember it is up on the wall, right under the air conditioning, I have the word C, it's not even a word, the letters CES painted. That is secant, the abbreviation spelled backwards, and it's also cosine with an E instead of an O. So that's there to kind of help you. It kind of looks like cosine, and it kind of looks like secant. And they are flips of each other. So that's painted there kind of to help you with that. Okay? So either one of those can help you. The last one is cotangent. And cotangent is the flip of the tangent. That one you really shouldn't need a trick for. Cotangent and tangent, for crying out loud. It's the same word. Now, speaking of SOHCAHTOA type stuff, as we know, sine is opposite over hypotenuse. And if we take 1 over opposite over hypotenuse, that is simply hypotenuse over opposite. So the cosecant of an angle in a right triangle is the hypotenuse over the opposite, simply the flip of the sine. Secant would be the flip of the cosine, which would be hypotenuse over adjacent. And then cotangent would be the flip of the tangent, which would be opposite over adjacent. So the cotangent would be adjacent over opposite. So if you made the SOHCAHTOA word with these, you would get probably something that didn't spell anything. Choshakao, whatever. But you could, if you wanted to, do something like that. The cosecant is the hypotenuse over the opposite. The secant is the hypotenuse over the adjacent, and the cotangent is the adjacent over opposite. It's easier, in my opinion, to remember SOHCAHTOA and then remember the flips. And so then you just flip the ratios in SOHCAHTOA. Okay? All right, so an example. Here we have a right triangle, and I'm asking to find the 6 trigonometric functions of angle A. Well, 3 of them we already knew how to find, And the 3 new ones, all we're going to do is take the 3 that we knew how to find and turn them upside down. So I'll go through all of them with you. We are dealing with angle A, so we're standing on angle A. So what you can do from the very beginning is you can label all of your sides right now, because we're going to be using them, the same labels, throughout the problem. So standing at A, I know right off the bat where the hypotenuse is. If I'm standing at A, the furthest side away is the opposite side, so that's 4. And the only side that's left, the leg that's next to the angle, is the adjacent. If you write those down at the beginning of the problem, you never have to figure it out again in the problem. You never have to look again. The ones that were working last hour were struggling with that. They'd have to re-find the opposite over and over because they would forget which one it was. The sine of A, opposite over hypotenuse, 4 over 2 root 13. Can't have a root on the bottom. So we have to rationalize the denominator. We talked about that some last week. Multiply the top and bottom by root 13. I get 4 root 13 over 26 because the bottom becomes 2 times 13. And then 4/26 reduces as a fraction to 2/13. Simply taking opposite over hypotenuse and working our Chapter 6 magic from first semester. Cosine, same idea, but it's adjacent over hypotenuse. Rationalize the denominator. Three root 13 over 13 is what you end up with. Simply adjacent over hypotenuse and simplify. Opposite over adjacent for tangent, very simple. 2/3. I could have asked you that question last Thursday or Friday. Now, the secondary trigonometric functions, all we're going to do is we're going to flip the correct trig function that goes with the one I'm asking for. So cosecant goes with sine. CS, the cosecant, goes with the sine. So we're going to flip sine. I am not going to flip the final answer. Because if I flip the final answer, I'm going to have a root on the bottom again. So I'm going to flip the first thing I wrote down. And then reduce that 2/4. I mean, you can reduce the final answer and rationalize the root 13 again. You'll end up in the same place. But after a while, you're going to screw up at some point with all that root multiplying. So I flipped the one that was easier, where there was no root in the bottom. Secant is the flip of the cosine. So I'm going to flip the first one again, 2 root 13 over 6. 2/6 reduces to 1/3, but we don't write the 1. I wrote a ghost 1 there just to show you how that's working. 2/6 reduces to 1/3. And then cotangent, you just flip the tangent. So all we're doing is turning those upside down. That really doesn't take math ability. And that's really all there is right now to the secondary trigonometric functions. We'll talk more about those later.